This video is about finding intercepts on a graph. Now, we'll find them algebraically, and I will also show you how to find them on the Casio graphing calculators, like the ones that I have for my students here in the classroom. Just a reminder, intercepts happen when we have one of our values being 0. So if we're looking at xy coordinate pairs, when the x is 0, that's when we get the intercept where it crosses the y-axis. And when the y is 0, that's when we get the x-intercept where it crosses the x-axis. It's kind of nice to find them algebraically because I don't have to rearrange the equation at all. I just have to plug in a 0 somewhere. So if I put a 0 in for the x and solve for y, that will give me that y-intercept. That's what I'm going to do first. So over here, if I put in 0 for x, instead of multiplying by x, I'm multiplying by 0. And I'll just solve for y. Honestly, this all disappears because that turns into 0. So I really just have negative 6y equals 19. And don't be thrown off by the fraction. Fractions happen. It turns out y equals 19 over negative 6. So my y-intercept would be 0, negative 19 over 6. There's my y-intercept. Here, now we'll do the x-intercept. For the x-intercept, that means I'm going to put the 0 in for the y. So that's what I'll do next. I've got 14x minus 6 times 0 equals 19. So that means this part is going to go away. It turns into 0. And I've got 14x equals 19, really. If you still want to have the 0 there, you can, but you don't need it. And then divide by 14. So my x-intercept is 19 over 14. And I'll put that here, 19 over 14, and I have found my intercepts. As far as plugging in a number goes, well, 0 is the easiest number to plug in, so that's really not too bad. We'll do a few more, and then I will absolutely show you how to do this on the graphing calculator. Find the intercepts algebraically. We're going to do it just like that last problem. So I'll plug in 0 for x to find the y-intercept. That gives me 0 equals 9 times 0 minus 7y plus 2. So that means this 9 times 0 turns into 0. That just disappears. That's 0. So I'm going to ignore it now. I really just have 0 equals negative 7y plus 2. And that is what I would solve for y. So let's see. A few different ways we can do this. I'm going to add 7y to both sides. Bring it over here where I have more room. So that gives me 7y equals 2, which means when I divide both sides by 7, y equals 2 over 7. I'll put that right here. So y equals 2 over 7. This is my y-intercept. I turned x into 0. 2 over 7 is my y. Let's do the other one. When I put in 0 for y, then I get 0 equals 9x minus 7 times 0 plus 2. This whole piece right here turns into 0, so I'm going to ignore that. What I really have is 0 equals 9x plus 2. Well, I'll move the 9x to the other side. I could have moved the 2 and had the x on the right. Kind of your choice there. So I have negative 9x equals 2. Divide both sides by negative 9. I'm running out of room here. So I get x equals negative 2 over 9. And I'll put this over here, negative 2 over 9. So that's my x-intercept and my y-intercept. Okay, this is a good example because as you notice, there's not a visible y. That's okay. So I can plug in 0 for the x. So we can do this part of it. If I put in 0 for x and I want to find the y, well, then that looks like 9 equals 0 minus 4, and that doesn't work. Notice that what I end up with is 0 equals negative 4. When you get something like this, it just means, hey, it doesn't cross the y-axis. Oh, so not going to work. If you picture a graph here, that means if I have a y-coordinate and an x-coordinate, I have an x value here, then this is a vertical line where it always has the same x value. Here, if I want to know exactly where it is, I can solve for x. But if I did plus 4 to both sides, then I would get x equals 13. That's what I get if I solve for x, so, which means I would come over here to where the x is 13, and my line looks something like this. It does have an x-intercept. No matter what y is, x is always 13. So the x-intercept is at x equals 13. It never crosses the y-axis, which is why there's not a y-intercept. So just FYI, if something is going amiss when you're looking for your intercepts, well, it's probably just something with the graph. Maybe it doesn't have any. This is same idea, opposite case. Let's see, I could solve for y. I'm just going to do that. I'm going to solve for y. So I get 3y equals 20, and then I would divide both sides by 3. So I have y equals 20 over 3. Now, that means this is my y-intercept, okay? So my y-intercept, if the x value is 0, the y value is 20 over 3. Because no matter what the x is, the y is always 20 over 3. If I were to look at this graph, 20 over 3 is a little over 6, by the way. It's like 6 2/3. So let's say this is 20 over 3. It's up about 6 2/3. And my graph would look like this. That's why it doesn't cross the x-axis. There is no x-intercept. Okay, so we can plug in zeros all day long, and we can find the intercepts that way. But we're going to do things a little differently now. We're going to mess with the graphing calculators. So if you're in my class, then whenever you are in the classroom, you have access to one of these handy dandy Casio graphing calculators. Now, I'm going to work on following these directions here. If you're in my class and you have access to these graphing calculators, you might want to actually write these steps down, because it's so easy to forget what buttons to push. I'll be the first to tell you, if you're not used to them, then you can get kind of confused. So let's start by turning on the calculator, and usually we use it in this screen right here, but I'm going to press menu and select graph. So I do that. I press menu, and it has all these options, and I'm going to select graph. Right, so this top left, run math, that's most of my calculations and things that I do, just regular calculator stuff. Right below that is graph. So I'm going to just arrow down, and I'm pressing enter on the bottom right here, and I selected graph. So that gives me this. Notice that what I have is I can put in a whole bunch of equations, but it gives me y equals, basically. So then I type in whatever happens after the y equals. If it's not already in the form where y is alone, I sometimes have to do that. This one's all set up for me, so I can just type in negative 9x plus 3. So I'll type in, let's see, negative 9. And for the x, I'm going to use this button right here to make an x. And then that was what? Plus 3. So plus 3. See, it says negative 9x plus 3. Zoom out a little. Now, it also says then press the execute button. Once you type in your equation, you must hit enter. it will not accept the equation until you hit that enter button. If you haven't hit it and you try to graph it, it's not gonna work. All right, press F6 for draw. It's right here. See how it says draw above it? That goes to F6. All right, notice mine is all zoomed in funny. I don't know, I just grabbed one of the classroom calculators. I'll go to the window and I'm gonna make everything go, let's see, the X minimum to 10, enter. I'm just setting mine so it'll go to positive or negative 10 in all directions. And then I'll go back to draw. Okay, that's a little better. Usually they kind of zoom and move around kind of automatically. So here's my line. I've got my y-axis, I've got my x-axis, and here I've got my line. Press F5 for G solve. See where it says in yellow, G solve. So I'm going to press F5, and it gives me these options at the bottom. So Y, I, C, P, T, that goes to the F4 button. Y-intercept, press F4 for Y-intercept. So if I just press this button, what happens is it highlights the spot where it crosses the y-axis, and it even tells me the ordered pair. So see, x is 0, y is 3. So literally for this equation, the y-intercept, x is 0, y is 3. Right? If you can't really tell here, well, it tells you the numbers down here, and it's pretty clear about that. Now for the x-intercept, let's see, I'll go back to F5 for G solve, but this time I'm gonna press F1 for root, and it gives me the root, which is the same thing as the x-intercept in this case. So see, this one is a decimal. X equals 0.33333, y equals 0. So for the x-intercept, I would put 0. Oh, that's a terrible 3. 3, about y is 0. So if you have access to these, it can be a lot quicker. There's all sorts of other things that we can do with these and different values we can find. There's even different ways that you can find points on the line. So if I want, here, let me kind of go back. So if I press G solve, it gives me all these options, y-intercept and root for the intercepts. But see this arrow, I can go to the right and I've got y-calc, x-calc. That's where I can actually plug in a value for y. I wonder what the x value is when y equals 5. Well, and then it finds that spot on the line. When y equals 5, it tells me what the x is. I can do a lot of things with these. So I'm gonna delete my equation. Let's just try another one. Notice this one's not ready. I can't plug it in unless it's solved for y. So if I have something like this, I have to actually solve for y first. So I'd get 2y equals negative 5x plus 8, and then I would divide everything by 2. So I'm running into my next problem below that, but I get y equals negative 5 over 2x plus 4. This is what I'm going to plug in, and I'm going to do that. So I'll press the negative button, and I'm going to press this above the fraction. Or above the 7 is my fraction button, and that was what, 5 over 2, so 5 over 2, to the right, x. Notice I'm making it look exactly like this, okay? I'm checking, it looks exactly like that, negative 5 over 2x plus 4, and then I always hit enter, draw. So here's this one, and if I want to find my intercepts, G solve, y-intercept. My y-intercept, where x is 0, y is 4. So my y-intercept is 0, 4. That was easy, right? Okay, and then G solve again, root. Okay, looks like my x-intercept is at x equals 1.6. So my x-intercept is 1.60. And just like that, I found my intercepts. Just a heads up, sometimes you get different looking equations like this, y equals 2. Well, let me exit, come back to here, delete that one, and I can just put in y equals 2. Yep, horizontal line. Now, if I look for the y-intercept, that'll work because it does cross the y-axis at 0, 2. But if I go to find the root, where is it? It's not there. Well, that's because it doesn't cross the x-axis. I can see that. If it gives you some sort of error, if it says not found, well, maybe there isn't one of those. Okay, now one more thing. This is the very last part of this video. So sometimes we don't have a y, which can be a problem because, I mean, look, I'm supposed to put y equals and then my equation. I don't have a y, I have an x. Well, I can switch to x. So go into your graph just like before, and since it doesn't work, since you don't have a y, you're gonna press F3 for type. See where it says type? That's over the F3. So I press F3. And then it changes the menu on the bottom. And I see the one that says x equals. That's what I want. So I'm gonna press F4 to get that x equals. Now, instead of y's, those turned into x's. So now I can always type in x equals 4. And of course I have to hit enter. And then draw, and now I have a vertical line. And of course if I do gsolve, it doesn't give me anything. That's because vertical lines are not technically functions. But I could always do gsolve, and I could, what if I put in, let's see, is it gonna let me, what if I do xcalc? Oh, maybe it won't let me. Will it let me do ysolve? Nope. That's okay. Honestly, you're almost never going to be working with vertical lines, but at least you can get it on there if you need to. And if we're doing a system and you want to find where two lines cross, you can graph these on there and you'll be fine. So I encourage you, if you're in my class, do as much as you can on the calculators, get used to using them. That way it'll save you time on tests too. I'm glad that we have these Casio calculators this year. That's all for now.